I am going to go ahead and talk about Web5. And the title of my talk is On Wednesdays We Use Web5, a Mean Girl's Guide to Data Sovereignty. So, first, to introduce myself for folks who don't know, my name is Rizel Scarlett, and I am staff developer advocate at a company called TBD. Now, it does not stand for to be determined. Before I joined, I thought they were still deciding on the name, but it stands for to be decentralized. If you wanted to connect with me in the future, my handle is at Black Girl Bites. So, what we're doing at TBD, we're actually a company within an incubator company within the organization Block, which is also owns Cash App and Title. But what we're doing within TBD is we're building something called Web5. And today I'm going to show you why it matters, what it is, and how you can build with it. But before that, I want us to get to know each other a bit. I know there's not too many people in the chat right now, but that's all right. So I'll just start out by letting you know that I'm a baby millennial, aka like I was born like a little bit like just at the cutoff of being a millennial. And that means I grew up in like the early 2000s. Like when I was 5, I think it was 2000. And that means I grew up with some awesome different like TV shows and stuff like that, such as Bratz, That's So Raven, like songs like Crank That Soldier Boy. And then I also love the song I Write Sids Not Tragedies by Panic at the Disco. So if there is anybody in the chat, I don't know, but if you are in here, feel free to share your favorite show or movie or song that you're loving right now, or something that you remember from the 2000s. But I will move forward. So one of the movies, another movie I really love, and why it's focused or called On Wednesdays We Use Web5. I love the movie Mean Girls. It was iconic. Anybody that is my age that watched it, hopefully y'all watched it, will tell you it's an iconic show. But if you've never watched it before, or movie, it's an iconic movie. But if you've never watched it before, I will give you a little bit of a recap, right? So the main character's name is Katie. She's played by Lindsay Lohan right here, and she attends public school for the first time. She's like a transfer student that was like homeschooled in South Africa, and her plan is to essentially take down this popular clique at the high school. They're called the Plastics, and the reason why she wants to take them out is because she wants to expose them for being manipulative. But in order to do that, she has to get in there. She has to kind of become one of them. So to become one of them, sorry, hit my mic, but to become one of them, she has to kind of get accepted into the group, and she starts like doing their little theme stuff. So like they coordinate their clothes and everything. So for example, on Wednesdays, they wear pink. That's like a slogan in the whole show. But she also finds out that the Plastics have something called a burn book. This is where they write rumors and secrets and insults about other girls and even some of the teachers at school. Some of it's really malicious content, some of it's kind of silly. Like I remember they're like Amber Dialisio, I don't know how to say her name, made out with a hot dog or whatever, like little rumors you would say in high school. And the idea is that no one is ever supposed to be able to see this content besides them. So it's a private book until the leaders of the Plastics, the leader of the Plastic gets upset at everybody, and she's like, you know what? I am mad, and I'm going to distribute all the pages of this book. So she photocopies it and she spreads it all around school because she's upset. I believe they said something bad about her on the book, and she's like, I'm not for this. So now everyone's secrets are out, including the teachers. There's zero privacy. So I heard in 2024 they're airing a reboot or a sequel of Mean Girls called Mean Girls 2. Here's the twist. For this talk, we're going to pretend that we're cast in the movie Mean Girls 2. So here's what's happening. Principal Duvall wants us to rebuild the burn book digitally with Web5. So you might be wondering, why would he want to rebuild it when it caused so much chaos? Hindsight is 2020, and 20 years later, he's realizing how important it is for students to have self-expression. But he wants to avoid the problem where rumors get spread and friendships get ruined. So he's like, maybe the solution is students get to vent, but they have control over their privacy and they get to decide who gets to see what. And he heard that you could do something like that with Web5. So he's employed the best and brightest software engineers, aka us, to lead the initiative. We tell Principal DeVoe, okay, we'll agree to it for a hefty price. And we'll start with an MVP first. And if you don't know what that stands for, it stands for minimum viable project. So we're gonna do the basics. And he's like, okay, that sounds good. He agrees to it, but we also admit to him we don't really know too much about Web5. So we're gonna need a little bit of training. So for us to be able to build this whole thing, we're gonna learn what Web5 is, we're gonna learn why it matters, we're going to follow the quick start guide that they have, and then we'll build our own Web5 application in the start of a burn book. So let's talk about what is Web5. Um, Web5 is an ecosystem that enables developers to build decentralized applications that prioritize data ownership and user privacy. Let me just check the StreamYard just to make sure. Cool. There's just people saying hi. Just wanted to make sure there's nothing in here. That was a good movie. Thank you, Tim Trueblood. All right, we're going back. So Web5, just to repeat, is an ecosystem that enables developers to build decentralized applications that prioritize data ownership and user privacy. Now, it's not something that we just came up with out of the blue, and this is a legit thing, right? So basically, the W3C, which stands for the World Wide Web Consortium, created identity standards. They're starting to think of like, what does identity look like in the future? Maybe it's not username and passwords. And what we did at TBD is we created a framework to apply those standards. So basically, W3C sat down and said, all right, here's the future of identity. Here's how it could work. Maybe you don't have to use the username or password anymore. They wrote a whole bunch of words. And then the team at TBD was like, here's the code that can make this work. So here's the main concepts of Web5 that we'll quickly go over: decentralized identifiers, decentralized web nodes, and verifiable credentials. Starting with decentralized identifiers. They're also called DIDs for short, or DIDs. People use it interchangeably. In the Web5 ecosystem, every single user has a decentralized identifier, and that's represented as an alphanumeric string. So it starts off with the letters DID, which is the scheme. Then you have the DID method, and then after that, you have a DID method specific identifier. DIDs are essentially a W3C open standard. They're based on cryptographic principles. I want to emphasize not cryptocurrency, but cryptographic, and they're not tied to one application or system. They can actually replace the need for a username and password. I don't know if y'all have ever seen my friend, you might not have, but I'll let you know. My friend Will Johnson, he's a DevRel over at Okta, and he has this really great talk. And he says in the talk, I ain't got no more passwords in me, bruh. I love that line so much. And that's totally okay if he does it, because DIDs remove that need for authenticating with a username and password. DIDs use cryptographic keys like a public and private key pair to identify who you are on the web. Kind of like when you use a YubiKey at work, you just like insert it into your laptop and it knows who you are and logs you into everything. That's kind of how the experience is. But here, you don't even have to type in your DID. You don't have to remember it, because Web5 can the Web5 ecosystem can automatically pick up on who you are. Your DID also gives you access to something called a decentralized web node, which people have shortened for DWN, and that acts as your personal data store. So when you think of decentralized web nodes or DWNs, you can kind of think of Dropbox, but this one is your personal Dropbox. And here's the reality of products like Dropbox. This is not like coming at the product or anything like that. Love them. But products like Dropbox, because they're centralized, they can change their terms of service, they can access your data, they can even shut down your services, leaving you without access. And here's the thing, DWNs don't do that. They provide a personal space where your data is stored and you decide who gets access. And you might be thinking, who cares? I get it. I was the same at one point. I'm like, this is how the internet is. I don't know anything else beyond that. But here's the thing. Today, users don't own their data. Like, I don't own my data on the internet. Our data, as you can probably tell, is often sold and exploited for advertisements. If you've ever been sitting down and you're just thinking about, like, I don't know, Oreos, and then you see a commercial for it and you're like, what? How did you know that? Because it's it's getting our data. These applications are feeding our data, getting our data, and then selling it to other companies for advertisement purposes. And we often think we have ownership of our data because we can do things like create accounts and content, but behind the scenes, companies can just delete our accounts if they wanted to. And even if you did delete your account on your own, platforms could essentially retain our data for unknown purposes. So here are some moments where lack of ownership has backfired in the real world. Recently, someone tweeted that PlayStation essentially sent out a message saying, like, hey, some of the digital games that you paid for and owned aren't going to be there anymore. We are removing access because we're not supporting it anymore or whatever. People are outraged. They're like, I paid for this. I should still be able to have access to this. Here's a case where maybe decentralized ownership could solve. Another example, if y'all have remembered, Twitter recently rebranded to X, and it caused a whole bunch of commotion, including the fact that they're like, okay, our username, the Twitter username is Twitter. But now that we're rebranding to X, we're going to change our username to X. Here's the thing, that handle already belonged to someone, or so he thought, until they sent him a message that said, like, Dear X1234567, whatever the user handle associated with account X is affiliated with our organization. So they essentially just took this person's username. It did not belong to him. And that made me be like, oh my God, like my branding is Black Girl Bites. And if someone took that, I would be so upset. Another thing is things like forgetting my password. I am locked out of my first Twitch account that I've ever made because I forgot my password, and then it wanted me to go through like two-factor authentication to just confirm who I am, but that was on a different phone that I owned. So I was forever locked out, and now my Twitch handle has to be Black Girl Bites 1. Another example is there's often discontinued products. If if you haven't, check out Killed by Google, and they've essentially like discontinued a whole bunch of products. One of them is Google Podcast, which my manager, Angie, was pretty upset about because that's what she uses. So she's like, dang, that's all the stuff that I was listening to on the daily gone. Another example is lost data. I recently saw that about 578 people have messaged to Google support that their files in Google Drive have suddenly disappeared. They only can see everything from May 2023 and before. Also, I wanted to just mention that even the inventor of the World Wide Web intended for the internet to be a place where we owned our data. His name is Tim Berners-Lee, if you don't know. And here's a little quote from him. He says, I think the public has been concerned about privacy, the fact that these platforms have a huge amount of data and they abuse it. But I think what they're missing sometimes is the lack of empowerment. You need to get back to a situation where you have autonomy and you have control of all your data. Here's the last concept I wanted to introduce to you all before we actually go ahead and build our application is this idea of verifiable credentials. Verifiable credentials are essentially like digital proof of your identity. And here's the cool thing, TBD within Web5 is not the only ones working on this. There's known organizations such as Okta that are working on verifiable credentials today. And you may have even used verifiable credentials or something similar in the past. For example, some states have issued digital driver's license. So now you can just show your driver's license on your phone. You don't have to carry around the card, which will be great for me. I wish Massachusetts would do it because I lose everything. And then also some people have had digital COVID vaccine cards. So maybe you're going into a building and they're like, hey, you need your vaccination card, and you've been lost that little tattered up paper card that they gave you at CVS. So now you can just show it on your phone. I wanted to quickly show a website called verifiablecredentials.dev that was created by Okta. So if you were curious on a little bit more about verifiable credentials and what they could look like, Okta is actually like working on this. I don't know if it's necessarily a proof of concept, but I'm really excited to learn more about it. But like, here's an example. They have like an ID card, a university degree, vaccine proof, and proof of employment as well. All right, let's head back over here. So just wanted to end this portion, not the whole thing, but end this portion by saying, like, let's step into the future. Let's embrace the future of privacy, so that we'll have rights over our data and we have control over when our data gets deleted. And when it's deleted for real, and we get control over who can see our data. So what we're going to go ahead and do is we're going to start kind of coding ourselves. But before I do that, I do want to check the chat, just double check if people have questions. Oh, awesome. Just Brian said he got locked out of an account for a similar reason. Yeah, sucks. All right, so let's talk about how we would store data in our personal data store called the decentralized web node. Now that we know what Web5 is, we need to be able to put data in there, retrieve it, and so on and so forth. Here's the awesome thing. A lot of times before I got into this idea of decentralized identity, when I would hear people talk about it, it sounded super complicated. It is a paradigm shift, but here's the part that I found that's been really familiar to me. Web5 uses a familiar concept for me, which is CRUD, and that stands for create, read, update, and delete. Many software developers, I don't want to speak for all of them, but they may have used this in their own careers, where maybe you have to do API calls where you're doing a get, a post, and so on and so forth. It uses these very familiar concepts. So what I'm going to do is I'm going to go ahead and go to the quick start guide. If you wanted to check it out, you could. It's at developer.tbd.website/docs. But I'm going to go ahead and follow the quick start guide and kind of code live for you all. So let's go over here. Sorry about that, y'all. All right. So one of the first steps on the quick start guide, and I wish I could show you both at the same time, but that's all right. So I've already installed the package that we need, which is the Web5 API. So I don't need to do that part, and I've imported it as well. But the next thing we want to do is we want to actually create a record in Web5. So first thing I'm going to do is I'll just paste this in here. Hopefully it's legible enough for you all. But here's what we have, right? So the first thing we want to do is we want to automatically connect to the Web5 ecosystem. So we're going to get that, and we're going to get this instance of Web5, and we're also going to get our decentralized identifier. I'm going to name this Rizel did because my name's Rizel, not Alice. So what we can do just to see the proof of this is I'm going to console log my own did. And we're going to run it. Oh. And I'm going to go ahead and do node quickstart.js. All right, and you can see your did is this long alphanumeric string, but don't worry, you do not need to remember it because you can just take it around with you. But as you can see, it starts off with that schema that I told you about. It starts off with the method ion, and then here's this thing that identifies who I am. All right, next thing I want to do once I have my did is I actually want to store something inside of my DWN. So I'm going to go ahead and copy this, and I'll comment this out. And what I'm going to do, so I'm going to store some words. I don't want to say hello world 5. Maybe since this is a Mean Girls themed, we can say so fetch. For those who watch Mean Girls, you get the reference. So I'm going to go ahead and console log that and see what that gives us. So what it's doing, right? I'm creating the record, and then it's getting stored in that DWN. And I'm telling it the data format, it's text plain. It's not like JSON or MP4 or whatever. You can store whatever type of data you want in here. So if I go ahead and run this, we'll see this object. It's a lot in here, right? But it's just information about the record. It kind of says who created it. So I'm the author right here. You see my did. You could see what type of method I used. I used the write. We can see when it was created, and so on and so forth. All right. Next part we want to do really quickly is we actually want to read that method or that record. We want it to print back out to us. So I'm going to go ahead and comment this out just so we don't get too confused. And I'm going to go ahead and do something like this. and this is going to read our record for us. I'm going to press console log. Read result, and what we should see is the words "so fetch." Once I print it out, I'm gonna clear my console. Oh, it's not really in an async function, I guess. So let's see. Really quickly, maybe I can do async, something like that, and then return it. And okay, and then I'm just gonna call main. Hopefully this works. For some reason, when I code live, I forget everything. Record is not defined. Oh, duh. It's because I uncommented this out. I didn't even need to do all what I was doing. All right, I'll take this back out of here. All right. Okay. Let's run this again. And here we go. We got the word "so fetch." So we so far have been able to write our record. We've been able to read the record. And now we actually want to update the record. Hopefully I don't make a mistake here. So in terms of updating the record, we're going to do something like, hopefully, all right, cool. So I wanted to say that maybe I could say making Web5 happen. And maybe let's see if it actually console logs this updated result. Maybe we'll see that I have an error, and that's all right. Record's not defined again. I keep doing that. Here we go. So this basically gives us like, hey, it was successfully updated. So maybe what we need to do next, if I could remember, is maybe we could actually get the record out of here. So give me a quick second. What we want to do is this. There we go. And there we go. So we have the updated result, and it says I'm making Web5 happen. And then last but not least, we want to go ahead and delete that record. So I'm going to grab this, then do that. And we're just going to go ahead and see that this result was actually deleted. And I think what will make the most sense here is if I take this part out, and it's just going to say like, hey, this was successful or not. And it may not be. Yep. Let me see. Well, oh, here we go. Duh. I'm like trying to read the deleted result. Here we go. There we go. Awesome. So it was successfully deleted. So within all of that, we got to see like me writing a result, which said "so fetch." Then we got to read it, and it printed out that it was like successful. And we also got to see that it said "so fetch." After that, we updated it to say I'm making Web5 happen. And then after that, we deleted it. So we got that part out. Someone said, where are these records stored? On her local PC. So there are, let me just double check some of the chat and crowdcast. Awesome. Thank you. Thank you so much. So this is getting stored on locally on my local DWN or my local data storage. And people don't get access to it. But I will expand a little bit more to see if that helps you to gain more understanding. Let's go back to our slides. So that was just the quick start guide, but we'll go even deeper. So next thing I want to show y'all is creating DID. So you saw that you can automatically create a DID, but you can also do it just like on your own, like manually. So here's some examples. We're not going to watch me type it all up, which is really great. So we don't have to get tired. But basically, here we have different ways or different methods of DIDs, right? So you have different types of DIDs. You might have a DID ion. They all do have different purposes or return slightly different data. So and this is just like within the entire decentralized identity ecosystem. Many different companies make different types of DID methods. So if you wanted to make a DID that was like a DID key method or a DID DHT method or a DID ion method, you can use Web5 for that. So as you can see here, we're just going to make a DID key and a DID DHT method and we'll print it out. I'm going to go ahead and run this. And I'm going to do node index.js. And here we can see, this is a lot, but here we can see first it created the did key method for me. And then underneath it has a did dat method. And it's a little bit like there's a little bit less information in the did DHT method. Even the did alphanumeric string itself is a little bit shorter as well. So especially shorter than the ion method that we were using before. So they all provide different benefits depending on like why you want to use it. All right. And so sorry, Brian. I know I'm like switching between coding and slides. All right, cool. So here's the next thing I want to talk about. And protocols are where the magic happens. I think for a long time, and let me go back to where I was reading my slides for myself. Here we go. So for a long time, I was like, how exactly do you accomplish this data ownership part where you're deciding who can read the data, who doesn't have access to the data? Because all I'm seeing is like we can store data in our DWN, but what else? And basically, you use something called protocols. And protocols are just JSON objects that one structure your data and help you decide who gets access to that data. So here we can see in this example, I've defined the protocol and at the bottom, we have something called actions. Well, first, let me go right here. And the data within my protocol is called a DING. It's going to be using this schema, and the data format is going to be application.json. But skipping ahead to my favorite part, which is this actions array, it decides on who can be able to create this type of data in your decentralized web node, who will be able to read the data that you create, and so on and so forth. So here we can see that anyone that uses my application can write a DING, but only the author can read their own DIG, and only the recipient can read their own DIG. So basically, only if I sent Brian a message, we would be the only people that would be able to read that DING. All right, so we're gonna go ahead and jump into building our burn book. And let me show y'all what I'm doing and how. We will switch into the code really quickly. So I'm gonna do this really fast. If you did want to follow along, and I guess I should have given Brian this link, but maybe I'll show it to you all in the end. Let's see if I press join chat. No, I'll show it to you all in the end, and I'll just paste it into the private chat. So what you can do if you wanted to try this out on your own in the future is I created this little starter tutorial that you can follow through, but here's how we're going to start off. First, right now, we have this web application. It's half finished, right? It has some of the structure in place, but it doesn't have all of the Web5 methods. First thing we want to do is actually initialize Web5 once the project loads. So what I'm going to do is within my use effect method, I'm using Next.js and React. So if you're familiar with Next.js, you'll know, but basically right now, as soon as my project loads, I want it to create a DID and I want it to connect to the Web5 ecosystem. And then I'm also going to have it set those state variables for me. Next thing I will want to do is I want to go ahead and create my protocol. And we kind of seen an example of this earlier. So I'm going to look for where we define this protocol right here. And what we can see is I have our burn book. this is like the data structure and who gets access to it and how it's going to look. So our burn book is going to have two types of data. We're going to have secret messages that only we ourselves can see, and then we're going to have direct messages where we can maybe share a message with one person. So here's the rules of interaction for our secret messages. Only anyone can write a secret message, but only the person who wrote the secret message will be able to read it. And then in terms of direct messages, an author can read their own direct message. A recipient, whoever received that direct message, can also read it, and anyone can write it. So here's a big difference between the two of them. With a secret message, only you can read it. Only you, the person that wrote it, can read it. And within the direct message, you're saying the person I sent it to can read it, and I can read it. Okay, next thing we want to do is we're going to do something called querying our protocol. So when I say that, and I'll put both of them, or yeah, let me put both of them so we can see it. Sure, I'll focus. But basically, we're querying a protocol, right? So everything is stored on the DWN, including the rules of how you structure your data. That includes your protocol. So here we've defined our protocol. It's going to get written to our DWN. But first, we're going to check our DWN to see if that protocol already exists. And that's why we're searching for it. We're like, okay, hey, DWN, do you see a protocol that matches this URL that we've specified right here? And then next thing we want to do, I'll also do it for the remote protocol. So you have a local DWN and a remote DWN as well. The next thing you want to do is you want to be able to install it. So installing it is basically creating this shared agreement that, like, yes, I agree to using this application's protocol, and like anyone that goes onto the app. So you get the choice if you want to do that. So I basically have this method that's called to install it if the person is looking to interact with the app, with the DWN or with my DWN. So the overall logic, which is, it sounds confusing, but the overall logic is going to be, first, you define the protocol. Then after that, you search to see if the protocol already exists on the DWN. And if it doesn't, it'll install the protocol. And if it is already there, it's just going to say it's already installed. And let me check the time. Okay, we're doing pretty good. Next thing I want to do is I want to create the methods for actually writing messages to our DWN, or basically just handling, like, hey, how do we handle like creating a secret message or creating a direct message? So we'll start with creating a secret message. When we create a secret message, what it's going to do is basically what we did earlier when we saw us do like the create method in the earlier quick start example where I said so fetch. So it essentially does that same thing where I pass in my data, which is going to be a message object. And so it's not saying so fetch because it's not plain text anymore. But it's also going to specify different things like, hey, we want to follow this protocol. We want this to be a secret message type, and we want it to use the secret message like structure, these actions, these interaction rules. And after that, we also specify who it's going to get sent to, and specifically, it's going to get sent to myself. So my DID. It's not going to get to send to anybody else, as opposed to the direct message. The direct message behaves very similarly, but instead of saying, hey, the recipient is going to be myself or my DID, the recipient instead is the like person I'm sending it to. I'll like insert inside of an input box somebody's DID, and it'll pick up on that and insert it. And the rest of it is essentially written out for us. So when we press the submit button, what's going to happen is it's going to double check if it's a direct type of message. And if so, it'll decide between who's the target recipient. Either it's the person that we wrote in the input box or it's ourselves. And once it does that, it'll construct our message for us and it'll write it. And we also have and here's our message object as well. Here's the text that we're sending in. It has a little bit of more information like the timestamp, the sender, what type, is it a secret, and I also have a support for image URLs. After that, the next thing that happens is we just have something that handles fetching or retrieving those messages. Very similar to what we did in the quick start, where we basically just query the DWN and we're like, hey, we don't want all the records from the DWN. We only want the records that match this protocol and have this particular direct message schema, or in terms of secret messages, we want it for the secret message schema. I think I scrolled past it too fast. But let's go ahead and try this out. I am going to go to the final example of this, and that is over here. We are almost done. I'm surprised how well I did on time. Okay. And I feel free to ask questions after. Hopefully I am able to answer. So I'm going to go ahead and run npm run dev to get this project going. And the way that I can, I think something else is running, but that's okay. The way that I can test this, because I'm not two different people, is I can open a regular browser and an incognito browser as well. Let me check the comments before I move into that. Awesome. Ebony has answered some questions. Hi, Erin. Awesome. Okay. So what I'm going to do is I'm going to open up maybe this browser. Here we go. We got localhost 3001. Alrighty, so I'm gonna maybe split it in half. I wonder if I can do that. And then maybe incognito mode. All right, so we can see them side by side. Localhost 3001. Okay, cool. So let's try out just sending a secret message to ourselves. Demo gods, be with me. All right, so I'm just gonna say, hey, this is my own secret message. And I'm gonna press submit message. And here we can see immediately that this is like my own secret message in my burn book. No one else can see this. If I want to say, OMG, like, I don't know, teenage angst. What do teenagers say? I hate my mom. I don't know. I never hated my mom. But whatever like secret message you wanted to put in here, you can. And you have the ability to also delete it. But let's try out maybe sending a message to someone else. We're going to try sending it to this person in incognito mode. So I'm going to go ahead and copy this person's did. I will paste it in, and I'll switch this to saying I want to send a direct message. There we go. I'll paste in the recipient did right here, and I'll say, hey, can you see this message? Question mark, and I'll press submit. And so on my side, I can see that I sent it, and I don't have like it automatically pulling, so I do have to press refresh, but awesome. Here we saw that I sent this direct message to this person, and I essentially have control over who can see this data that's being stored in one in my DWN just by the basic interaction rules that I've specified. I can also try sending a message. So I'm going to look up like image, not a message, an image. I'm going to look up an image of Mean Girls, and I'll take this URL. Let's see, just want to make sure. Cool. And I'm going to go ahead and say, hey, it's the Mean Girls. And I'll put this image URL in, and I'll press submit. So we see it on my side. Let's see if we see it on the other person's side as well. Here we go. Let's go back to our slides now that we've seen this demo working in action. So many different monitor or screens I have. I need like millions of monitors. But anyways, so right now we see that we can send messages to ourselves and to trusted friends. But we can add so much more. Principled of all things, we're off to a really great start. So for example, we can do stuff like incorporate the use of verifiable credentials, which I mentioned earlier, for things like moderation and reporting, where users can report inappropriate content and moderators can issue VCs to mark actions taken, or even something as simple as maybe the students of the school saying, hey, this is a trusted friend. I'm giving out a trusted friend verifiable credential, and I'm enabling people to perform actions on my post or messages. Maybe I say, since you're a trusted friend, you're allowed to comment on it, or you're allowed to, I don't know, screenshot or whatever. So if you wanted to get started with Web5, you can definitely use my project as a jumping off point, but definitely feel free to just let your imagination soar. Here's some other use cases for Web5, maybe a place to store all your music playlists in one place, full review apps, voting, social media, a personal data vault. I seen this really awesome project that someone made with Web5 where he put all of these boring documents in there, like documents you don't want to read from end to end, such as like your renter's insurance. And then he incorporated AI into it. So he used the vector database, and basically he can talk to this AI chat assistant and say, hey, when does my renter's insurance expire? Or when does this happen? Or whatever information he needed instead of reading it all. I thought that was really cool. Or you can even use it for healthcare data management. If you did want to learn more, you can check out the TBD website. I should have put a QR code, but I forgot to. At developer.tbd.website, you can check out the TBD devs blog or my own blog at Black Girl Bites Dev. And you can also follow me on social media. My handle is at Black Girl Bites everywhere except for Twitch. And that is it. I am open to questions.
Thanks, Rizel. That was really, really interesting. I love the demo. Love the Mean Girls references. Even though I am not a millennial. I'm Gen X. Old.
That's okay. If you love the Mean Girls references, that's all that matters.
That's what matters. Okay, so we did actually have some questions from the audience. I pulled down your slides here. Okay, so first of all, first question was how much data can you store in that DWN?
I've got to double check, but from my knowledge, I don't think there's like a limitation of how much data you can store.
Okay. And so when you say it's stored locally, like locally in the browser would be like is that like in local storage, or because you said it's stored locally
Yeah,
and remotely. It's locally,
yeah,
it's going to be like local storage somehow, or is it in
yeah. So let me just double check. So just to give a disclaimer, I'm still like 2.5 months into the job, so I'll make sure I don't say the wrong thing.
oh, don't
uh,
worry.
So yeah, from my knowledge, you do have it's like local to your computer from my knowledge, but I will double check once I get the answer to just make sure I didn't say the wrong thing. I'll message you
Oh,
just so you can make sure it gets out to everybody. But let me see. What Ebony says is yes, you don't have to worry about you. Okay. No, but yeah, from my understanding, it is local to your computer, and then we do have like servers with remote DWNs as well.
okay.
But
So is that like that's where TBD comes into this, is the remote DWN storage? Is that's kind of like what you would use TBD for?
TBD.
Yeah. Because you said it's a web
Mhm.
standard, but it's also like it's there's remote if there's remote DWNs, I'm assuming that's where you'd like loop in TBD,
Okay,
and that's
let
what
me
you
see if
all
I
would
can.
eventually charge for, right? Yeah.
Okay, so Ebony explained deeper browser memory, but I don't. So that's where the local would be. But when TBD, the part that TBD comes in for, I think is more of the framework itself. Like that's how I would think of it, is more of the Web5 framework itself.
Okay.
But yeah.
Okay. Oh yeah. And I'm gonna for those, because some folks are on
Oh yeah, can they see that?
Crowdcast.
They
I'm
can
gonna
see
copy
the.
some of I'm gonna share some of what Ebony has said here on the screen, so that we can get
Yeah,
to
I think that
everybody.
was. Yeah, and I think that was to Tim Trueblood, where he said, "Is the idea that I don't store user info in a SQL
Yeah.
database or no SQL database." Yeah,
Yeah. And so like yeah, she says that you have to give permission and yeah, and it's stored in browser memory. Okay.
yeah.
Thank you, Ebony, for answering
Thanks,
all these
Ebony.
questions. Okay. So on Crowdcast, Ryan asks, how do people verify ownership of DIDs? Like he says, for example, if anyone can make a DID, then another person can copy and pose as that DID.
They can't copy and pose as it, because it's using like the cryptographic principles. So just as if you wouldn't, I think you can't like how with your YubiKey, you can't just take someone else's YubiKey and like plug it in and be like, oh, that shit is that. Hold on, I want to make sure that's a good analogy. Mm. Or
Ebony?
if you were
Okay.
like, yeah, I don't think you can take some the whole point of a YubiKey is you can't log in as somebody else, right? So that's how I try to think of it. Whereas using a private and public key with cryptographic principles. So even if you had their DID, you couldn't just run around and use it because it has to like it knows who you are from like your actual computer and all that.
Okay.
Yeah.
Um, so yeah, so I think it's basically it's just an ID. It doesn't actually have like it only has whatever information you've shared about yourself effectively. Like so it doesn't actually know who I am. It's
Yeah.
just an ID.
Yeah, just to hold on. Let me clarify. I feel like I'm making it confusing. But yeah. So it doesn't have like this is Rizel Bob Simple or Rizel Scarlett or whatever. It doesn't have all of that information, but it just has like basically you're like a private key and public key pair. So it's like this is this person's particular ID and wherever they are on the web, it'll log them in or give them authentication to that specific space.
Okay. Okay. So let me see. Um, I'm looking at my notes for questions.
Go ahead, go
um,
ahead.
yeah. So Aaron asks, so it's okay. Is it like a call to confirm the key? So that's
What does that
effectively what
mean?
you're doing with the SDKs. You're confirming the key with that uh, um, remote DWN. Sorry, learning terminology, and the local
Yeah.
DWN, and like and then getting whatever information is stored there.
I want to make sure I understand you all. So, okay. So, when you do like Web5 Connect and it created that did, I might have went a little bit fast. I don't know. Can I share my screen really quick so I show you all?
Yep, you can share your
Okay,
screen.
cool. Because I think it will be better explaining if I share my screen. Um, so right here where I call Web5 Connect and it creates a did for me, that does like one generate the did, but it also gives me access or authenticates me to my specific DWN. I think that's what you were saying, Brian, but I want to make sure that I said it right
Yeah, I
or
think.
answering your question right.
Yeah, I was trying to phrase Aaron's question. So I think yes.
Okay.
Yeah. Okay. I think that does answer it.
Okay, cool.
Um. Okay. Very cool. And I wasn't even aware that like this was a web standards thing. Because um, there was I think between Web 3 and Web 5 and Web 2, it's like I'm like I don't know. I can't get.
It's like another version, but it's not. So the Web5 title, I do think that confuses people, and it confused me too. I was like, this is another version of Web3, but it's really just a play on the name of,
Yeah.
of Web3. So they're just like, hey, we like some of the ideas that came from Web3 where maybe things should be decentralized, but this is not necessarily on the blockchain. It's just essentially just creating decentralized applications without necessarily needing the blockchain. So it's like we like these ideas of Web3 and we like these ideas of Web2. And instead of like, oh, replacing everything, we want to combine both and like give these Web2 technologies that. But yeah, I know it can be like another version of Web3 and you might feel skeptical.
Yeah. So that was I think what until I started digging into it, because once you proposed it was like, okay, let me dig into it. I don't really know anything, and then it's like, okay, this is not really like a Web3, I mean, to me, it's almost like, okay, we're replacing what would essentially be like we'd use like someplace like an Auth0 or like some other authentic identity provider, but you're actually using a web standards based identity that's cryptographic, you know, and that's what essentially sounds like to me. Like
Yeah.
you could, in theory, replace those kind of identity providers with this kind of identity provider, which makes sense if you can eliminate the need for passwords and stuff like that. Um,
Yeah, I
I
think of
know.
it that way too. Sorry,
I
go
mean,
ahead.
it does sound a little bit like back in the day there was. It, you know, still kind of exists, but OpenID was an attempt to make everybody have like, but it never, it wasn't really like a web standard, built-in web standard kind of thing. So, um, yeah, maybe a little like that as well.
Yeah, no, I think so too. I when I like first started diving into it, I'm like, okay, there was like I think that's like another step into like how we authenticate. Like first we had username password, then we had like multi-factor authentication, and then we have like I know GitHub started using pass keys. And so like this
Mm.
is like an additional like, hey, let's make it even easier type of step. And it does have like some calls out to like more retro things, like you said, like stuff from back in the days. Yeah.
Yeah, yeah, exactly. Like Mean Girls.
Yeah.
Is that built into the protocol?
I would love
All
that.